You're going to need a calculator. So let me get my calculator ready here. So don't worry, yes, you can use Desmos, but the issue, guys, is that when you take our exam, you're not gonna have you're not gonna have Desmos around. You're gonna just have your calculator. So let me reset my calculator. Do you guys know how to reset your calculator? Second memory or the plus symbol, and then 712. All right, so here we go. So what are we doing? All we're doing is we're taking two sinusoids. Sometimes this is called a linear combination, and we're turning it into one sinusoid. Chop, what are you talking about? So do you see how I have a sinusoid here, -8 cosine theta, and I have another sinusoid here, 3 sine theta, and we're adding them. There's a plus symbol. And we're turning this into one single sinusoid with a phase displacement. Chop, why do we want to do this? I don't understand. In engineering, sometimes it's easier to analyze one signal than it is to analyze two signals. And maybe right now you're like, okay, I don't necessarily see the point. But as we start, don't worry, we'll start doing application problems and you'll start seeing how this can be beneficial. So what are we doing? All we're doing is we're taking two sinusoids and we're turning them into one. Cool or not cool? Okay. How many of you have already taken physics? Or are you guys all mostly in physics? Okay. So maybe you've done this in physics, maybe you haven't. I'm not sure. Have you ever had to find like a force value in the x direction and then the force value in the y direction? No? Okay. All right. So let's see. Let's see if we can transform. So I have -8 cosine theta plus 3 sine theta as a single cosine with a phase displacement. So, Chav, what does that mean? I'm turning this -8 cosine theta plus 3 sine theta into a single cosine with a phase displacement. So that D is the phase displacement, right? Like how much you move it. And then that A literally stands for amplitude, which you guys already knew that. And then that D is my phase displacement. Really, I didn't even want to put that letter as a D, but they have formulas here that use the letter D, so I went ahead and obliged. Are we still okay, guys? Nothing crazy, right? Okay. You see this -8? It's in front of the cosine. So whenever you're doing physics, like whenever you're trying to find the horizontal component of a force, you use cosine. So this -8 is like an x value. That 3 is in front of the what? Sine. So that 3 is like a y value. Does that sound familiar to you guys? Like from physics or no? No? Okay. Maybe. Okay. So this is like saying -8, 3. So I'm going to go to quadrant 2 and I'm going to put a point at -8, 3. So here's -8, 3. I'm going to make a reference triangle. So connect it to the origin like so. This is -8. This is 3. This is like your amplitude right there. And then what's angle D? Angle D is like this one right here. Are we okay so far? Nothing crazy, right? All right. If I wanted to figure out the amplitude of this right triangle, notice -8, 3, it's a right triangle, guys. I can use what theorem? Yeah. So I can say 3 squared plus -8 squared equals a squared. Or you can just go right into it and just say a is nothing more than the square root of 3 squared plus -8 squared. Let's see, square root, 3 squared is 9, 8 squared is 64, so square root of 73. Is everyone okay with that? Square root of 73, I don't know, it's some number that goes on forever, so just leave it at square root of 73 because it's not a perfect square root. All right, how am I going to get angle D? Well, I'm going to find the reference angle. In my opinion, this is the easiest way. If you want to, in my opinion, this is the easiest way. Just anytime you're finding your reference angle, guys, all I'm doing is SOHCAHTOA and just turn that -8 into a positive because you're just finding the reference. Remember, the reference angle is always positive. So, Chav, what are you talking about here? So, with respect to the theta r, tan of theta r, tan is opposite over adjacent. And yes, you could use sine and cosine because technically we do have the a square root of 73. But usually, since you're given these coordinates, the 3 and the -8, or the -8 and 3, x and y respectively, you usually want to use tan because it's going to be opposite over adjacent like that. So tan of theta r is equal to opposite over adjacent. I don't see any issues. I think we're okay so far. Are we okay so far, guys? All right. How do I get theta r by itself? By doing the inverse. Inverse tan or arctan of 3 over 8. And you're not going to add anything to it. I mean, if it were something like a cycle or 2 cycles, you'd put plus pi n or 180 n, but we're not going to add anything to it. So I take my calculator. I'm in radian mode. Or do you guys want degree mode? Doesn't matter to me. Keep it in radian. Okay. Arctan of 3 over 8. And I'm going to push enter. And there it is, 0.35877. Oh, man. 0.35877. That's not the angle we want, but we're going to use that to help us out. What is the angle from here all the way to that to the negative x-axis? What's that? Yeah, 180, or if you're in radian mode, we call that pi. So angle D is nothing more than pi minus theta r. Do you guys see that? So pi minus 0.35877 will give us our answer. Will give us that angle, angle D. So let's see what that is. I'm going to go pi minus this number. Now, notice this number actually goes on forever. So it's cutting it up. So it is going to be an estimate. So it's not going to be perfect, but it's going to be pretty close. 2.782821. 2.782821. At least 3 digits. 2.78. I already forgot it. 2.782821. 2821. Okay. So what does that mean? That means that negative 8 cosine theta plus 3 sine theta is the same thing as square root of 73 cosine, open parenthesis, theta minus 2.782821. And don't worry, we're going to check it right now. I'm going to put the word check it. Check it. Chav, how are we going to check it? I'm going to type the original. Negative 8 cosine theta plus 3 sine theta into y1. So take your calculator. Go to y1 and put, what was it? Negative 8 cosine x, close it, plus 3 sine x, close it. There it is on y1. And on y2, I'm going to type the new one that we just got. Square root of 73. So square root 73, open parenthesis, cosine x minus, and should I start using memory? No. 2.782821. 2.78. I already forgot it. 2821. 2821. The more digits you can put in there, the better. All right, check it out, guys. I guess let me turn off Y2 first. Let me turn it off. So here's Y1. On yours, if you don't have a colored screen, you're not going to be able to see it. I'll make Y2 thicker so you can see it. Here's Y2. So I'm going to turn it on, and let's see if the blue gets erased with the red here. Oh, what happened? I didn't turn it on. I didn't turn it on. Here we go. Enter. And now it's on, and look at that. It's the same. Isn't that cool? And in case you're wondering, Chav, I have the old screen. I can't tell. Let me get my old screen. Here it is. So here's your old screen. That's what you guys have. How do I make it where I can tell? Let me show you guys. Negative 8 cosine x plus, was it 3 sine x? Okay. And then hook me up with my new one. What was it? Square root of 73 cosine. Oh, let me get out of there. Hold on. Cosine of x minus what? 2.1. Okay, here's how you can do it, guys. Go all the way to the left. All the way. Do you see that little line here like this? Go all the way to the left. So that one should be blinking like that. See how it's blinking? Push enter. And now you're going to have a thick line. See how it's thick now? So when you push graph, look at that. Mine does it really fast, but I guess I can slow it down. But look, see, look, let me turn off Y2. So there it is. So look, graph. There's my y1. And then when I go back and I make y2, I turn it on. Check it out. Boom. And it's the same thing. Isn't that cool, guys? Now I know we have Desmos, and Desmos is probably the way to go. But you're not going to have Desmos for your exam because it's going to be a paper exam. Let me go back to my color screen. Are you guys not entertained? Are you guys not happy to be back? I'm so happy that we're back, guys. We got to keep going. No? I think we got to keep going. What happened, Rodriguez? Oh, be happy, miss. Are you happy? All right. Did you guys like this? How you can go from 2 sinusoids to 1? Or you guys don't like it? It's chill, and it's easy to do, right? See? So here are some formulas, guys. Don't be a robot. Do you have to use arctan? No, you don't have to use arctan. It's ideal, but you don't have to use arctan. You could use arcsine. You can use arccosine. But it's just ideal. So put that in your notes. You don't have to use it. You don't have to use arctan, but it's ideal. Why is it ideal, Chav? Well, because they give you cosine and sine, and that's an x and that's a y, and you can do arctan of y over x, and I'll give you your angle most of the time. If you're in quadrant 1, you don't have to do this if you're in quadrant 1. Check it out. Well, I guess let's just do some more examples. All right, so go to example 2. So notice the 4 is in front of the cosine. So this is like an x. The 3 is in front of the sine. So this is like a what? Y. So it's like an x, like a y. Chav, I don't understand why it's like an x, like a y. In physics, when you remember, right? In physics, when you were finding like your force in the x direction, you have to use cosine. You find your force in the y direction, you have to use sine. It's something similar to that. Not 100%, but the ideas are the same or similar. So since this is like an x and this is like a y, it's kind of like saying like your vector type of thing. I'm going to exaggerate quadrant 1. I have a point. That point is 4, 3. Connect it from the origin. So this is like your reference triangle. So this horizontal displacement is like a 4. This vertical displacement is like a 3. This is your amplitude. And this is the angle D. Do you guys see what we're doing? All right. Because you're in quadrant 1, you're not going to need to do any type of edit for arctan for the angle. I guess let's do the A first. My A. All I'm doing is Pythagorean theorem, guys. You probably already know it's a Pythagorean triplet, 3, 4, 5. But in case you don't, just go square root of 4 squared plus 3 squared. And no, that is not 7, 4, 5, 6, 7. Nope. The square roots and squares don't cancel out. You gotta do them individually, guys. 16 plus 9, and then the square root of 25, because that's what that adds up to. That's a 5. I know some of you guys already knew that was a 5 because it's a 3, 4, 5 triangle. Are we okay? Are you guys not entertained? What's going on, miss? Oh, okay. All right. Are you guys okay so far? All right, here we go. Now I'm going to find that angle. I'm already in quadrant 1. Guys, there's no need to do anything with pi. It's just whatever arctan. I'm just doing SOHCAHTOA. SOHCAHTOA. And I'm just skipping one step, so I'm just going right into it. Arctan, opposite over adjacent. 3 over 4. And whatever angle this is, that's my angle. So I'm just going to take my calculator. I'm going to go second quit. Arctan of 3 over 4. And I'm going to close it. I'm going to push enter, and I get 0.6435. 0.6435. That's my angle. So here we go. I'm just going to write my equation. So what am I going to do? I'm going to write 4 cosine theta plus 3 sine theta is equivalent to 5 cosine, open parenthesis, theta minus 0.6435. So it's this. A cosine with a single phase displacement. So I come back and I'm going to check it. So I guess I can write y equals 5 cosine theta minus 0.6435. And there it is. That's my answer. And I'm going to type this into y2. I'm going to type the original into y1. So go to y1. I'm going to clear both. Clear, clear. And I already forgot. What was it? 4 cosine. So 4 cosine x plus 3 sine y, or 3 sine x, sorry. So there it is. Enter. And then on y2, I'm going to type in what I just got. 5 cosine x minus, and I already forgot what that angle was, 0.6435. 0.6435. It's not going to be perfect because I'm cutting it off, but it's going to be pretty close to perfect. Check it out. So here is, I'm going to turn off Y2, guys, just so you guys can see what's up. Remember, my calculator is pretty fast because it's on a computer. So there is my blue curve or my blue sinusoid with this. And look, watch, check it out. I'm going to turn it on and let's see if it overlaps all the blue. Boom. And look at that. Isn't that cool? If we were to look at a table, and I know initially like, oh, it's perfect. It's not because we rounded. Look at that. Let's see how many values of digits. So it looks like it is perfect to like 6 digits after the decimal. 1, 2, 3, 4, 5. And then after that, all these change. Look, see? See? So it's pretty accurate. Even though we're rounding, it's pretty accurate. You guys are not entertained? You guys don't like this? It's fun, right? No? Okay. Yeah, it's another hack, guys. Don't worry, we're gonna learn more. All right, check it out. You know what? Let's change this one. Change. Oh, relax. I'm just gonna change a plus to a minus. Put a minus. Put a minus. Minus. Because I want to be in quadrant 3. Because I just realized we don't have one in quadrant 3. All right. So this negative 15 is like a x, and then this is like plus a negative 8. So that negative 8 is like a y. So really, it's like a negative 15, negative 8. So I want to turn these two sinusoids that I'm adding up into a single cosine with a phase displacement. So plot this point. So quadrant 3, negative 15, negative 8. So I'm going to say that that's negative 15, negative 8, not to scale. Draw a right triangle. Here's negative 15. This is negative 8. This is your amplitude. And the angle D is this one right here. That's the actual angle. Are we still okay? All right, here we go. I hear popcorn. A equals the square root of negative 15 squared plus negative 8 squared. If you want to be technical, you can leave the negatives in there, but anything that's negative squared is going to be a positive number. If that is another Pythagorean triplet, guys, but if you don't know it, that's fine. I believe that's going to be 8, 15, 17. It's going to be 17, but if you don't know it, that's fine, guys. Just use your calculator. Square root. I already forgot. Did I say? 8 squared plus 15 squared. So 8 squared plus 15 squared. Look, it's going to be 17. It's one of those Pythagorean triplets from geometry. You guys remember them? No? Okay. It's okay if you don't. Google, write down Pythagorean triplets and Google that sometime in the next 3 days before you take an ACT or SAT. It'll help you be pretty fast it'll help you recognize them. You know what I mean? So put somewhere there Pythagorean triplets, and then Google that later on. So this is 17. So that's what my A is. The A is never negative. Are we okay so far, guys? All right, now I need to figure out what the D is, the angle D here in blue. So before you do that, notice, let's see what color. I'm going to pick purple. I'm going to find this one first, theta R. So here's a good one for colored pencils. I'm in quadrant 3. So I'm going to go theta R equals arctan of 8 over 15. Opposite over adjacent. Notice that I didn't put them as negative. Why did I put them as both positive, guys? Because the reference angle is always positive. Does that make sense? So I put them as both positive because the reference angle is always positive, and I just did opposite over adjacent, so katoa. So here we go. I take my calculator, and I'm going to go arctan. So let me clear all this. Arctan of, was it 8 over 15? Okay, so there it is. Enter. And there it is, 0.489957. 0.489957. All right. To figure out angle D, the distance from here in black, from here all the way to here, that is pi. So then I got to take the pi and add 0.489957. Do you guys see that? So I take the pi, and I'm going to add plus 0.048997. Let's see what that is. Let me go back to blue. So pi plus, and I'll screw up here. And there it is, 3.63154,998. Let me see if I can remember that. 3.63, nope, can't remember. 154,998. 154,998. All right, so here's my equation, guys. Y equals 17 cosine theta minus 3.63154,998. If I didn't make any mistake, that should be equivalent to the expression I have up here. I'm about to find out. Here we go. I take my calculator. I go to y equals. I'm going to clear both of them. And I'm going to type, I already forgot, what was it? Negative 15 cosine theta. And then minus, it was 8, right? 8 sine theta. And then on y2, what did I get? 17 cosine x minus what? 3.63154,998. The more digits, the better. All right, let's see. I'm going to turn off the red one, or y2 first, because I want to see y1 first. So here's y1. Oh, you know what? Let me go up a little bit. Window. Let's go up a little bit. Negative, let's see, what's my amplitude? 17, so negative 20 and 20. Okay, now we'll see it. All right, y'all ready? And no yawning, that's a demerit, miss. All right, here we go. Let's see. I'm going to turn on y2. And I'm kidding, YouTube. I don't give demerits for yawning. And look, it's the same. It's the same graph. Isn't that cool? Are you not entertained? So there it is, guys. So do you guys think we've done enough examples for you guys to tackle this? All right, so let me pass out your handout, and that's it. It's only 6 questions, so we should